All right, hello and welcome. Today we're going to tackle something that might sound a little scary at first, linear equations. But stick with me because I promise by the end of this, you're going to see that this stuff is actually super simple and, dare I say, kind of fun.
So let me ask you something right off the bat. What in the world does finding a single point on a map have to do with solving a math problem? I mean, they seem like they're from completely different universes, right? Well, believe it or not, the connection is this. They're both all about finding one, and only one, unique solution. A single specific point. So let's dive in and see how we get there, starting from square one.
All right, first up, let's look at the absolute foundation, the building block of it all, an equation with just one unknown and one solution to find. So, this is what we call a linear equation with one variable. And the name says it all, right? There's only one letter we need to solve for. That's our unknown. And here's the key. Its power is always just 1. So you're not going to see any squares or cubes or anything fancy, just a plain old x. Our whole mission is just to find that one single number that makes the equation work. Okay, let's make this real with a classic example. 2x plus 5 equals 11. The whole game here is to get x all by itself on one side of the equal sign. So first things first, we got to deal with that plus 5. And how do we do that? We do the opposite. We subtract 5 from both sides. Boom! That leaves us with 2x equals 6. Now we're close. To get x totally alone, we just need to undo that multiplication by 2. So we divide both sides by 2. And there it is. Just like that, we get our answer. X equals 3. That's it. For this equation, there is one and only one possible answer. It's a single, perfect point on a number line. So clean, right? Okay, so that was the warm-up. Now, this is where things get really interesting. What happens when we throw a second unknown variable into the mix? This is where we jump from a simple point into a whole new dimension. You see, with two variables, like an x times and a y, we're not just hunting for a single number anymore. Nope. We're looking at a relationship, a kind of partnership between x and y. And the coolest part? When you map out all the possible pairs that work, they always, and I mean always, form a perfectly straight line. Let's look at this one. 2x plus 3y equals 12. Think about it. There are tons of pairs of numbers that could make this true. Like, if x is 0, then a little quick math tells us y has to be 4. If y is 0, then x has to be 6. What if x is 3? Then y has to be 2. You see what I mean? There's an infinite number of solutions. Every single one is just another point on that same line. So, if we want to find just one specific point, one single answer, we're going to need more information. And this, my friends, is where the magic really happens. To nail down that one unique point, that single solution we're looking for, we need to introduce a second equation. That means we have a second line. And our answer? It's the exact spot where those two lines intersect. It's that single point they both share. This whole process is called solving simultaneous equations. All that means is we're looking for that one special pair of x and y values that makes both equations happy at the exact same time. It's the point of intersection. And the good news is we have a couple of really powerful tools in our algebraic toolbox to find that exact spot. First up, we've got the substitution method. Now, the logic here is actually pretty clever. You take one of the equations and you just solve it for one of the variables, like getting x all by itself. Then you take that little expression for x and you plug it, or substitute it, into the other equation. And check this out. That makes one of the variables disappear. It turns a tricky two-variable problem back into a simple one-variable problem, which, hey, we already know how to solve. Okay, method number 2 is called elimination, and this one is all about power moves. The goal is to line up your equations and tweak one of them, maybe multiply it by a number, so that one of the variables has the exact opposite coefficient. So you'd have, say, a plus 3y in one equation and a minus 3y in the other. Why? Because when you add those two equations together, poof, the y terms completely cancel each other out. They're eliminated. And what are you left with? You guessed it, a simple one-variable equation that's a piece of cake to solve. Okay, so solving this stuff with algebra is great, but here's what's so cool. We can actually see the solution. We can draw a picture of it. So let's head over to the graph and see what these equations actually look like. Now here's a handy trick. To draw any straight line, you only need 2 points. That's it. And the two easiest points to find, by far, are the intercepts. You've got the y-intercept, that's just where the line hits the vertical y-axis, and that always happens when x is 0.
Then you've got the x-intercept, which is, you guessed it, where the line crosses the horizontal x-axis, and that's always where y is 0.
And check out how easy this makes things. Let's take our equation from before, 2x plus 3y equals 12. To find the y-intercept, we just pretend x is 0. A little math, and we see y is 4. So that's our first point, 0, 4. Then, to find the x-intercept, we set y to 0. And that gives us x equals 6. Our second point is 6, 0. All you have to do is plot those 2 points on a graph, connect them with a ruler, and bam! You've just drawn the line for that entire equation. All right, we've got the theory down, we've got the mechanics. So now for the big question, when are you ever going to use this? Let's put it all together and see how this stuff shows up in the real world. Okay, check out this classic word problem. It just looks like a couple of sentences, right? But it's actually a math problem in disguise. The real skill here is translating the English into the language of math. So let's break it down piece by piece. The sum of two numbers is 30. Okay, let's call the smaller number x. The next part says one number is twice the other. Well, that means the larger number must be 2x, right? So now we can put it all together. The smaller number, x, plus the larger number, 2x, equals 30. And just like that, we've translated that sentence into a clean, simple equation, x plus 2x equals 30.
And now we're on home turf. This is the easy part. X plus 2x is just 3x. So now we have 3x equals 30. Divide both sides by 3, and we get x equals 10. So if our smaller number, x, is 10, and the larger one is twice that, well, the numbers have to be 10 and 20. And there you have it. We just used a little bit of algebra to solve a real-world logic puzzle.
All right, let's do a super quick recap of the key takeaways here. First, linear equations can have one variable or two. Second, when you have two variables, that equation is really just a straight line on a graph. Third, to find the one spot where two lines meet, you can use those two awesome tools, substitution or elimination. And finally, you can draw any of these lines yourself just by finding the two simple x and y intercepts. So that brings us to the big final question. Now you know the secret to finding where two lines cross. Where else can you use this? Think bigger. What other real-world systems could be understood just by finding their single point of intersection? You know, like in economics, finding that sweet spot where supply meets demand. Or in business, finding the break-even point where your costs and your revenue are exactly the same. The truth is, these intersections are everywhere, and now you have the tools to find them.